If you were to search for Twitch chat integration, you would likely get plenty of examples on how to implement it or videos of people using it. Do the same for YouTube chat integration and the results are either not relevant, too niche in explaining the process, or just aren't as popular as the results for Twitch. Why is that? I asked myself several years ago and started searching for, well, anything. Some solution had to be available considering the existence of stuff like chatbots made by Moobot, Nightbot or Stream Elements, or Stream avatars with its bobbing sprites for more interactivity, or heck, even a large amount of GitHub projects that were last updated a year ago or more. Eventually I did manage to get something working, and after a few years of experiments, I figured I may as well post a general idea on how to set it up and give some reasons why games might only offer Twitch integration right now. There are 3 things that'll be needed: an API key for the service being used, and on your programming language of choice, a way to perform GET requests and parse JSON data. There are other theoretical solutions and approaches that you could use, but it would either take too long to explain them all, or there are other particular issues that I'll explain later. Just know that you don't need to use what is shown in this video if it does not fit your particular needs. Anyways, first things first then. The API key for the service being used. YouTube offers direct access to all publicly available information of a live stream. All you have to do is search and log into Google Cloud that has all sorts of tools to use with your Google account, create a new project there, go to their library of API services and from there add YouTube Data API v3 inside the project, and finally go into credentials of your current project to create the new API key and make sure that it is given permission to use the YouTube API. Simple, right? There are direct links that can be used to access all of these parts, and I may have ignored a few details regarding security, but you can probably figure those out on your own. You're a developer, right? Now that we have the key, it's time to use the other 2 boxes. The API key will be passed to the GET request, while the JSON parser is going to be used to read the data received. First, a video ID for a live stream. That works. Next, we need to get the ID for the chat box. For that, we'll be making a request for the following page, making sure to add the key and the video ID in the correct positions. If everything goes right, you get a JSON message like this in return. There is a bunch of other useful data available here, but the main thing of interest is the active live chat ID text being shown, so we grab it out with our JSON parser with something akin to this. Next up, we have the following 2 URLs to continue with requests. The reason for the difference is that if we continue with the first one, it would always end up returning the newest 75 messages, including messages that have already appeared before. Not to mention, if the next call interval had more than 75 of them, some of those would end up getting lost. But that's getting a bit ahead of the given task. Once we use the first link with all the needed data filled, we would end up getting the following result. That's a lot to process right now, so let's just take out the most important parts. Much better. From this leftover data, we have the next page token, which will change each call and is used to only get new messages from the last call. The wait time is, well, it's not important right now, but it's the message display latency on YouTube's end. Finally, we have an array of all the messages found. Author details is all the user's basic data, and the snippet contains everything regarding the posted message. With this, we can leave it running, and over time, new messages will be collected. Everything should essentially be ready for basic parsing, unless I happen to be forgetting something in particular. Anyway, let's make some code react to it. For example, I'll write the message launch into the chat box, and after a set amount of time passes, of course, all of the usual events visible in the chat are usable on this, from memberships to super chats, and you can use it all to expand functionality. Filter out and listen to specific users? You can do that. Search for specific keywords? Why not? Make a custom polling system or other tools to increase viewer interaction? At this point, nothing should really stop you from that. An entire game around the concept? You could technically do that. I wouldn't recommend it though. Okay then, we have a proof of concept implementation showing that what can be done on Twitch is also doable on YouTube. So, why exactly have developers not been making any games with chat integration on YouTube then? Oh, you see, requests cost bandwidth, and bandwidth costs money. You may be inclined to believe that your request doesn't cost a lot, but when there are potentially hundreds of thousands of other services running simultaneously, it starts to add up on their side. Limiting how often you can use their service helps mitigate that, and also comes with bonus DDoS protection. As a comparison, let's check out how Twitch does this first. Going through their documentation in about 5 minutes, you get 800 points every minute, and every request costs 5 points. They may have updated their wording of this process recently, but overall it still amounts to 30 calls every minute, or 1 every 2 seconds. It also comes with a bonus where every user of the service is treated as a separate entity. Therefore, they have their own updating pool of requests. It makes the setup process easier for developers. Now let's look at YouTube, which has no info about this. You start with 10,000 points per day, which is shared across all the platform services, but for some reason, while their live stream service has documentation for setting it up, there is none for the costs. Like, the Quota page specifically mentions that the live stream features are related to it, but there is no indication of a separate page nor any info about it on the actual page. No matter. Through testing, I found that requesting for the chat ID costs 1 point, and requesting messages also costs 5 points. Ignoring the single point and making rough estimates, this means around 2,000 requests per day. Putting the same 2-second latency, this would mean a usage time of... Wait, that little? What if we increase the latency? Oh. While it's unlikely that someone would be using this for 24 hours in a row, this should still give a good idea on the core issue here. What's even more annoying about this is that there is an unmentioned issue. If the latency gets large enough, messages will be limited to the newest 75 between calls, causing information to get lost as before. So far, I've found that limit to be at around 10 seconds, but that may also be dependent on how busy the chat is. And what's more, there have been no mentions on the quota you're given being separated across users when using OAuth authentication. Everything written here is only in the case of one user. You can request for more quota. Google has an application form for it. But if you're not working at a company, the likelihood on it being accepted is quite improbable. Not to mention, probably getting monthly costs for it and whatnot. Oh, and because it's connected to the entire YouTube API service, like remotely uploading videos and commenting and such, any hope for it to get a separate quota system is also quite improbable. Something else that you may want to be aware of is that, unlike Twitch, YouTube does have some internal chat filtering, shadow hiding messages that break very particular conditions. I'm not talking about the ability to pick between top chat and live chat. I mean specifically hiding your message from everything without giving any notification. Imagine my surprise when I have run one of my projects on this channel for 8 months, and what few instances of people stumbling on it and interacting with it all got stuck in the exact same way. It was a puzzle where you had to figure out the correct IP address sequence and enter that as an input. It turns out all this time there were anti-doxing mechanisms put in, and you would never find out about it during testing unless you had a second non-streamer account going through the process. Ugh. Just be aware of that. One more thing that I found out was that if someone writes the exact same message a set amount of times, around 50 to 100, those start getting filtered out too, probably as a not very effective anti-spam method. If you have any ideas for implementations where the chat uses the text box like a controller, you may want to consider regular expressions and encourage users to write comments more enthusiastically, not just the command itself. When it comes to alternate implementation ideas, not only would this video get removed if I talked about web scraping, but it's also not a valid solution to what I want to achieve. That wait time given back by the JSON query that I mentioned before, it's also an indication to the actual display latency for users to see messages written by others. a scraper would be affected by that too. With the API, you have direct access to messages and are only bound by whatever delay you have set, and whatever the stream latency for the viewer is if you're visually showing the results. With an external tool, you now also have to wait an unspecified amount that it takes for messages to reach from one person to others. Streams of around a few hundred viewers have it around 2 seconds, but with thousands of viewers it can go up to 5 seconds, and in some very particular cases of hundreds of thousands to millions of viewers, I've seen it go up to 25 seconds. Not exactly a sustainable solution for larger creators, and you have no control over this. So, what to do with this then? First off, if you're not in a company to request quota extensions, but you want to make a project that many users can use, I would suggest putting the responsibility of creating an API key on them. It partially solves this shared quota issue and is technically TOS compliant, as each user is taking their own responsibility on how and where they use the API. And the second and more important thing is to take into consideration what you want to achieve and if it needs to be active all the time. In the case of either games or streaming, there are periods where you likely would not need any special tools for whatever issue you're having, either talking to the viewers or having pause periods for voting in games. And in all those moments, that amounts to more time left for the item to be used. With careful planning, it should be more than possible to stretch usage out to streams at around 3 to 6 hours in length. Either that, or you could make your own company. And that's pretty much it. You now know how to generally make an interactive experience on YouTube, as well as why it's not really done despite being possible. I'll keep on trying to figure out ways to make the whole thing better, but right now I've got a few other projects that I should have been working on 4 months ago. Good luck with your own projects though.